we're now going to see in action a teacher who gets it, who understands the implications of these new higher standards and who's using technology and creativity to help her youngsters learn them. So you're going to have a lot of fun, I think, in the next half hour. So again, Lauren is the Teacher of the Year from Wake County, and I think we have to move some stuff around, right? We need to get this out of the way.
One, I would just like to say thank you so much to the Hunt Institute just for inviting me to be here. It's an incredible opportunity. As she said, my name is Lauren Brooks, and I would be remiss if I didn't take a small moment of time to just thank you for your ears for listening. As a teacher and being a representative of the thousands of teachers that we have in this state, the fact that I've been given a voice to even be able to speak to this audience is an incredible opportunity that I don't take lightly. And so with that, my goal is to try to draw awareness into something that may be unusual or uncomfortable or even unknown. That's my goal in every day inside of my classroom. And so we're just going to begin with something very simple that I think most of you probably, having come through high school, have seen before. And it's okay if you don't know it, so don't be too intimidated as we begin to look into something about how the Common Core actually works and why it makes so much sense for really developing our young children as they're coming through high school and their new education. I'm very excited about the Common Core standards and what that means for my classroom, but also what I get to do as a teacher to dream about where we're moving as a country. And so that piece to me is extremely exciting. So what I'd like you to do, we're going to do a couple of group work activities first. So one of the first things that I'd like you to do is to find the 3 sheets that are on your table. There's 3 different pieces of paper. The one that you're going to need first, it says 7-6 quadratic equations or quadratic functions up at the top. Find that one sheet. Those other 2 you can put over to the side for a second. We don't need these right at this current moment. So if you'll find that quadratic 7-6 sheet and just review it for a second. Review quadratic functions for me as you begin to remember what you did in high school. Okay, hopefully that was plenty of time for you to remember everything you learned in Algebra 2. Look down at the bottom half of the page there to those written exercises and just give one of them a go. Based on the information that you've got at the top of the section, I'm assuming that you could maybe work on the bottom section. You can work with somebody next to you if you feel intimidated by that, but just try it. But as I move forward into thinking about education and where Common Core is taking us, it truly has changed our perspective on what students are doing and how they even perceive math in the classroom. I'd like to point out a couple of things on that worksheet that you just saw. So number one, and this is something that Dan Meyer, if you haven't seen his TED Talk, it's absolutely phenomenal. I would really suggest that you go look at that because it completely changed the way I view education and what's going on inside of mathematics inside of the classroom. But the first thing I'd like to point out is something that he called sitcom mathematics. I don't know if you have ever watched 2.5 Men or a sitcom like that, but when I was growing up and I was in high school, the mathematics that I would do was very similar to sitcoms, as in you would start a problem and you would expect it, in about 2 to 3 minutes to resolve its own conflict, basically like a sitcom does. Very similarly, we don't ever solve problems that are ever worth solving that are really like that. No math that really needs an answer will work out that way. You need to struggle with it. What was the purpose for it? Why did I need to know the answer in the first place? If the answer was just because I really wanted a cheeseburger, then so be it. But I need to struggle with the mathematics behind it in order for it to be meaningful and truly for me to have a deep understanding of why I did it. Now, when we were teaching or when I was taught how to teach mathematics, they said, just move to the textbook. It'll be a really great resource for you. Well, you have to really think about what the textbook really did for our students and for our teachers to really develop us to be on this very narrow pathway of not thinking, but just having a very shallow level of understanding. So we see here, if you look at the first top of the page, we have this example problem that has basic instruction, and it tells you exactly how to get to the answer. And then they're asked to Move to the written exercises at the bottom of the page. And instead of actually asking students to create their own thought and struggle with the material, just in case they didn't really understand what was going on, at the bottom of the line it says, follow the method of example 1. So let them not struggle. Make sure they know how to do the problem. It's never going to be real. And it's never going to be meaningful. It's right there. There will never be a chance for them to truly wrestle with the mathematics that they need to understand for true life. Because in all honesty, that's what mathematics is about. It's a beautiful subject. I love mathematics because it's a chance to use vocabulary to explain the world, the real world around us. But that's not real at all. And so as a math teacher, as I began to wrestle with that, I came across the way that we used to teach and how I was taught. And so I think this is not, a misnomer at all. One of the things you'll notice is that this is completely outside of context. There is no real world application. Nowhere in there does it say anything about where you would find quadratics in the real world. Nowhere does it give you an example. There's not even a picture of somebody that's actually doing this somewhere. It's just math for math's sake, or pure mathematics. We also see that we have the procedures before we have concepts. So why learn something? That's a really deep question. If I teach you how to do something, but I never teach you why you're doing it, then there's still no point to doing it at all. So a lot of times what teachers used to do is they would teach a procedure. They'd say, okay, this is how you create a quadratic graph. So these are the steps that you'd go through. And so you would look at the graph and you'd find the middle point and you'd look at that and how that makes sense. But nobody ever said, why? Why do that? Why is that important? And so we teach that backwards. And then we also found that I have a word problem that always comes at the end of the unit. And I'm sure everybody can somehow get back to the day when the teacher said, all right, we're going to do some word problems. And everybody goes, oh. It was that moaning and groaning day. And I actually still see that same pattern with 99% of my students that come through my door. I say, okay, we're going to start with a word problem. And you get this aversion to word problems that it's almost like an epidemic, that nobody wants to be near it, and it's contagious. Oh gosh, it's absolutely deadly. So this is how we used to teach. Okay, so this is how we teach now, and this is probably one of the things that I do in my classroom. If you haven't seen the concept of Angry Birds, you guys all received iPads or some sort of technology on your way in here, so that's great. I hope that you guys leave here and you go into your rooms and you guys download the app for Angry Birds and you play all night long. That's my goal, is to make you that interested in Angry Birds. But in case you've never played it before, it's a game where, and just in general, it's a game where the bird is upset at the pig. Just real simple. Now, why? Because the pig went to the bird's nest and he ate all the eggs. So he's really mad. So the whole concept for the bird is that he wants to kill the pig, or at least hurt the pig. Maybe not kill. So the concept of Angry Birds is that we're going to be looking at Angry Birds in a way that helps us to see quadratics. So we're going to play Angry Birds today. Literally, we're actually going to do some demonstration. We're going to play it together. We're going to experiment with what it looks like, and we're going to have fun with what that looks like. And so on your desks, what I've got is this sheet, if you'll find that sheet for me. And I just want you to imagine for a second. And you could take your pen and just individually, I want you to see if you could draw the path that you think how we could help the angry bird hit the pig. Real easy. Okay, so take a couple minutes to do that. Great, so basically what you guys have just discovered is the concept of quadratic motion, whether you know it or not. So this is where we are inside of our investigation. You have just now discovered that what goes up is really simple. And everybody's on the same playing field because everybody wants to hit the pig, right? Nobody doesn't want to hit the pig. We all want to help the bird. I mean, gosh, he got his egg stolen. You got to help him out. So if you can imagine what my students are like the day that I go, hey, take out your iPhones. Let's play Angry Birds. And we get really excited about that. So what I'm actually going to ask you to do now, just imagine what your graph looks like. And now I'm just going to give you a fair warning. I've got a low ceiling up here, but you can see we're setting up our little experiment over here. And what if I just said, I want you to try to hit the pig? Now, it doesn't necessarily have to be the second pig over here on the left side of the stage. I've got three animals, and I could only find one pig. So just pretend they're all pigs. But you can hit any of them, and I'm just going to ask for a couple of people who think they want to try to launch a bird to try to hit a pig. Anybody want to try to experiment with me based on what you did?
Basketball for Carolina,
Let's go. Come on. You've got it. Come on. Over there. I've got a launcher. You got it. All right. I need like 3 more people that want to try to hit the pig over on the right side of the stage just by launching. Does anybody else want to try it out? It'll be fun. I promise. There's nothing mathematical to this except experimentation. Sure. Great. Go ahead. Over there. I need like 2 more people. 2 more volunteers. Sure. Great. 1 more. Give me 1 more. Great. Thank you so much. All right. So I've got 4 volunteers. Give a round of applause for them, please. Thank them for getting up so you don't have to, right? Okay, so as a couple of things, I would say you feel free to do whatever it is that you need to do to get that, but I will give you a fair warning. I hit that ceiling when I practiced a little bit, so watch out for it. But the goal, again, is just to hit the pig any way that you want to. Let's see how he does. All right, a little bit over. You give him directions. Oh, he's pulling back. Oh, pretty close. That was a pretty good round. All right, good. All right, you can try. I was going to say, I'm going to let you go again, but I'm going to let everybody go through once. Let's see how we do. Okay, let's see. He's still in there. Ooh. Oh, very close, very close. This was way closer than the first time I did it with my students. This is great. You guys are better mathematicians than them. Here we go. Let's see what we got. Oh, okay. We got to think about that one. That one was really close. All 3 of them have been close so far. We're going to have to think about it. Okay. Okay. All right, so I'm just going to have you guys wait right there for a second. You guys did a great job. Just give me 30 seconds. Before I let them think about it, you guys are thinking, right? Okay, because I'm going to give you 1 more shot. Okay, so I'm going to let them think, but before they get to think about what they're doing, I want to hear what you guys think. Do you think that they need to make any changes? What do you think they should do? Go lower. Okay, so you got a comment over here that says maybe you should go lower with your slingshot. Let me hear somebody else's hypothesis about what they should do if they're going to hit the pig.
I think the bird needs to be bigger.
You think the bird needs to? I don't know if I could change that part. I would say I may be limited in my bird size, but maybe that would be a good thing to do. Anybody else? Huh? Get closer. Get closer. So maybe they want our slingshot to get closer. Okay, is that same thing? Okay, I'm going to ask you guys to amend your process by the comments of your peers. So we're going to use their comments to help us build. So they'd like you to move closer, slingshot. So maybe you tell me when. What do you think? That's good. It's your slingshot. I'm just here to watch. Is that good enough? We think? Okay, that's good enough. All right. So, and we also said that maybe attempt to pull the slingshot lower as we begin. Okay. So let's see if that helps us in hitting the pig. Okay. All right. Let's see. Let's give him 1 more shot. He was close first time. Oh, very close. Little soft. See if you can use his ability to help you learn what to do next. Oh, she's going mathematical. She lined that up. Did you see that? Ceiling. Oh gosh. I thought that was going to hit the ceiling for sure. Woo! Very close. All right, good. Up and over. So see if we can't, again, amend what we got. Okay, he's amending the people. Amending the holder. Okay. Come on, we got to have at least 1 successful one, right? Oh, gosh, that ceiling. I think if that hadn't been there, you'd have gotten it. I do. All right, last one. Let's see. Come on, you can do it. Last chance. Come on, Deb. Oh, hit the box. Good job. Give him a round of applause for helping me out. Good job. Thank you so much. Okay, so if I asked you to do this inside of my classroom, we would all participate and I'd give you all a chance to figure it out, but then we got to move forward and I'd say, okay, wait a second. So we've done this experiment, but I actually want to know mathematically or algebraically speaking, how do we help the bird hit the pig? I need to know it's not just a question. It's a real question, like a context question that I really do need to know the answer to, and we need to do it mathematically. So I, the teacher, say, what do you need from me? Is there some piece of mathematics that you know that you're missing or that you think would help you in order to figure this out? And so I would say to my students, okay, this is something that I think we need. The math that we are missing. To write a general equation, if I wanted to figure out the equation that would model what my students, what my bird would need to do as my students flung it across the room, this is basically what we're going to do. We're going to do some simple mathematics. So to write an equation that models something that goes up and comes back down, because that's what quadratic is, what you need to know are the roots. Well, the roots, just like the roots of your hair, are at the base. And so what we're looking for is where the graph touches the x-axis. And so if that's still intimidating language, just look for the x line on your paper for where the bird, as you see that line that's across the bottom of the page, it kind of matches up with the slingshot. And it's going to be a personal equation. There's no right answer. And there's really no wrong answer. Okay, but what I'm looking for you to do is to look for those dots that cross those lines. Can you find those dots on your personal equation, those dots where it crosses the line? Wherever those two numbers are, the numbers where your graph crosses the line, I'm going to take those two numbers and I'm going to plug it into an equation. So over here on the left side, you see my equation says y equals. I'm going to take the 2 from the equation and plug it in there. And I'm going to take the 6, and I'm going to plug it in right there. Can you try to make your own equation? Yours is going to be different from mine. It doesn't have to be 2 and 6. Now, in my classroom, I never let my students struggle by themselves, so I'd really like it if you had a conversation inside of your group, just the people that are around you. Make sure that they, as you look over, just make sure they're on the right track. And 2, if you don't think they are or you're both off track, see if you can work together to figure it out.